We're talking about exponential growth and decay functions, and we want to graph exponential growth functions and graph exponential decay functions. So in this case, we want to identify exponential equations. In order for that to happen, the domain will increase or decrease in regular intervals. So remember, domain is, we're talking about x values. And the range will change by a common factor. And remember, the range is, we're talking about y values. So the first thing we want to check is we want to check and make sure that the domain is increasing or decreasing in regular intervals. So to go from 1 to 2, we have to add 1. To go from 2 to 3, we have to add 1. To go from 3 to 4, we have to add 1. And to go from 4 to 5, we have to add 1. So the domain is increasing by regular interval. It's a regular interval of just adding 1. Then we can look at the range and see what's happening. So how do we go from 5 to 25? Well, in this case, we're going to have to multiply by 5. 5 times 5 is 25. As we go from 25 to 125, again, we are multiplying by 5. 125 to 625, we are multiplying by 5. And 625 to 3,125, we are multiplying by 5. So this is exponential. This is an exponential growth. And in this case, the common factor is equal to 5. The next one we're looking at is example 2. And again, we want to check the domain and make sure that's increasing or decreasing in regular intervals. So here we got 1 to 2 is plus 1, 2 to 3 is plus 1, 3 to 4 is plus 1. So the interval is increasing, so that's great. And then we're looking at our range, and to go from -4 to -2, this is going to be plus 2, so we're adding 2. From -2 to 0, we're going to add 2. And from 0 to 2, we're going to add 2. So in this case, we are not multiplying by a common factor. So really, this is not exponential, but this is linear. And in this case, we're not talking about a common factor, but we know that the slope is 2. The slope, or m, is equal to 2. Next one that we're looking at is example 3, and we're going from 0 to 2. So this one we're adding 2. We're going from 2 to 4, so that's plus 2. Going to 4 to 6, so that's plus 2. And 6 to 8, so that is also plus 2. So that's all set. And then we can look, if we don't understand, we're looking at this and we say 1/4 to 1. I'm not really sure how to make that jump. Well, how do we go from 1 to 4 and then 4 to 16? So we're going to do times 4 times 4 times 4, and then we can check with our calculator and say, yep, 1/4 times 4 is 1. So in this case, we are still doing exponential growth, and that is a common factor of 4. So that's the exponential growth, and that is a common factor of 4.